Okay, you guys, today we're going to be discussing 3-2 graphing from vertex form. And just for preference throughout the video, the parent function is right here in the top right hand corner, which is y is equal to x open parenthesis x close parenthesis squared. The actual equation is this one right here. Y is equal to a open parentheses x minus h close parentheses squared plus k. Now the first thing that we need to do is identify what each of these variables do. The variables being a, the h, and the k. Now the a, which you can see right here, I have listed them out. The a controls the width of the graph, whether it be narrow graph or a wide graph. So it would either look something like this or something like this if this was the graph. So that explains the A. Now the H controls left or right. Let me move this to the side a little bit so y'all can right there. Okay. Now if we have a graph right here, and let's just say this is the parent function, which is that up there in the corner. Now the H controls whether it's left or right. And the thing about the H is it's a little tricky. If it is a negative H, like it is here in the equation, that means it's going to be a positive value over here. So if it were to be a negative 4, then it would be 1, 2, 3, 4, and it would be right there. And it would be the same if it were the opposite. So if it were a plus 4, it would be 1, 2, 3, 4 to the left of the origin. And for the K, it controls up or down of the graph. So if I have the graph right here, and the parent function, if it were a positive k, obviously it would be up here. If it were a negative k, it would be down there. So let's start. We can go ahead and do a few examples now. Let's start off with something a little easy. Let's go ahead and do y. Move to the side a little bit. Y is equal to open parenthesis x minus 2 close parenthesis squared. Calculator real quick and enter that in. Open parenthesis x minus 2 close parenthesis squared and then we'll graph it. And you can see that the thinner line right in the middle, that would be the parent function, and the more elaborate line right there, that would be this equation. And as you can see, it's 2 spaces to the right because of this negative 2 right here. And remember, when it's a negative h, that means it's going to be moving in a positive direction. So if it were to be on a graph, it should look something exactly like it would on here. So we have the parent function here, and then 1, 2, just like that. Let's move on to our next one, something a little harder. Let's do y is equal to 3, open parenthesis x, minus 4 squared, and go into y equals and enter that in. Forgive me, take a little bit of time. 3, let's see, okay, there we go. 3 open parenthesis x minus 4 close parenthesis squared. As you can see, I've entered it in right there. and then you'll click graph, and there you can see it. The parent function's right here. The actual equation that we're using is right there. And notice that because we have an a which is greater than 1, that means that the graph is going to be more narrow than the parent function. So when you were to make a graph of it, it would be like this. So we have 1, 2, 3, 4, 4, 1, 2, 3, 4, 1, 2, 3, 4 for grins. Okay, so we'll have the parent function right here, and then this equation would look exactly how it is on here. So you would go, because it's a negative h right here, you would go 1, 2, 3, 4 places over here, and it would be a thinner, a skinnier graph than the parent function. So it should end up, I'll make it more elaborate so we can tell the difference between the two equations like it is on a calculator. It should be skinnier than the parent function. Okay, let's move on to one last problem, something a little more difficult, which involves the changing of all three variables, the a, the h, and the k. So we're going to have y is equal to 1/2 open parenthesis x plus 8 close parenthesis squared minus 4. And this time we're involving the k at the end. So go into y equals and do just that. You'll enter 1 divided by 2, which is the same as 1/2 open parenthesis x plus 8 close parenthesis squared, and then minus 4 at the end. And my calculator's too zoomed in right now, but you can see there's the parent function right there, and then you have our actual equation right here. And what that were to look like on the graph, because my calculator's too zoomed in, let's see, we'll have 1, 2, 3, 4, and we'll have 1, 2, 3, 4, 5, 6, 7, 8. And remember, this is the tricky one. If it is a negative h, then it's going to be over here in the positive area. But like it is in this equation, it is a positive h, so it's going to be over here. Let me move this to the side a little bit. Okay. And we also have this coming into play. We have the k, but this time it's a negative k, so it's going to be down here at this -4 spot. So, like it is down here, there's our parent function. So let's go and do that. Parent function. And because this right here, because a is less than 1, it is going to be a wider graph. So what we're going to do is we're going to go over here. Let's go ahead and plot these down. Go 1, 2, 3, 4, 5, 6, 7, 8 in the negative direction because it is a positive h, and then we'll go down 4, and it should something like that when you graph it on a piece of paper or a whiteboard like I'm doing. And there you can see the resemblance between the two. You have the parent function right there, which is the graph that we will base all these off of. And then, there we go, right there. And then we have the actual equation that we use up here, and because this is less than 1, this a, it is going to be much wider than the parent function. Right here we have a positive h, which means it's going to be in the negative direction, and we also have a -4 for the k, so which means it's going to be a negative down in the graph. Okay, that, my friends, is graphing from the vertex form. Hope that helps. Thank you very much.